Good afternoon. நம்ம இந்த வீடியோல என்ன பார்க்க போறோம் அப்படின்னா ஆப்பரேட்டர்ஸ் இன் பைத்தான் பார்க்க போறோம். ஸோ இந்த ப்ரீவியஸ் வீடியோல வந்து பாத்தீங்க அப்படின்னா அரித்மெட்டிக் ஆப்பரேட்டர்ஸ், ரிலேஷனல் ஆப்பரேட்டர்ஸ் பத்தி நம்ம பார்த்திருப்போம். ஸோ இந்த வீடியோல நம்ம பார்க்க போறது என்ன அப்படின்னா லாஜிக்கல் ஆப்பரேட்டர்ஸ் இன் பைத்தான். ஆக்சுவலா வந்து பாத்தீங்கன்னா பிஃபோர் லாஜிக்கல் ஆப்பரேட்டர்ஸ் பார்க்கறதுக்கு முன்னாடி ஜஸ்ட் ரீகால் இட் ஒன்ஸ் அகைன். ஸோ ஆப்பரேட்டர் அப்படிங்கிறது இட் இஸ் a symbol is used for perform certain type of some calculations. இப்போ ஆப்பரேட்டர்ஸ் இருக்கணும் கண்டிப்பா வித்தவுட் ஆப்பரன்ஸ் இல்லாம பண்ண முடியாது. ஆப்பரன்ஸ் மீன்ஸ் இட் இஸ் a value. So the values may be reside in memory or it may be directly we can specify. Okay. So now the classification of operators என்னன்னு பாத்தீங்கன்னா based on the number of operands it will be classified as a binary operator, unary operator and binary operator, and based on the functionality it will be classified as like arithmetic operators to perform arithmetic operations, relational operators for checking the relationship, and for logical operators to combine two or more relational operators, and bitwise operator to perform their operation in bit by bit level, and assignment operators and special operators. And these are the different kind of operators is supported by Python based on the functionality. So in this video, we are going to discuss the concept of logical operators. For logical operators, that means it normally is used to combine. The purpose of this logical operator is to combine two or more relational operations. So that here the input for the relational operator means a logical operator is a Boolean operator. That means that it is a true or false because the logical operators are used to combine two or more relational operations. So that the relational operations are the input for this logical operator. We know that the output of the relational operator is Boolean. So that the output of this relational operator as an input for logical operators, so that the Boolean as an input for logical operators. And for output, the output is also a true or false. So the output is also a Boolean, it is a true or false. Actually in Python, for representation of this true and false, there is a Boolean representation. There is no numerical representation will be allowed, like in Python, Java, C#, PHP. So like for this advanced programming language, there is a Boolean representation there, so that they are not allowed to go for any numerical representation. But in case of like C and C++, for Boolean representation, there is no specific Boolean representation in those languages, so that the Boolean representation true is represented as true for 1, and false is represented as 0. So in C and C++, the Boolean representation, we don't have any specific representation for Boolean, so that there is a numerical representation for Boolean values. So the true is represented as 1 and false is represented as 0. But like in Python, like Java and all, there is no numerical representation for Boolean because in those languages, there is a separate data type which is used for representation for your Boolean output. Okay. Now we move on to the different kind of operators. Logical operators is supported by Python. There are different kind of logical operators supported in Python. I mean, the logical operators are supported by Python. One is AND, OR, and NOT. So these are the three different type of symbols normally used to perform your logical operations. Okay, let us go to the first one, AND. So AND means that it is a logical AND. So the logical AND is like equivalent to the logic AND gate for logic gates. Okay, so the data type support, it means that the inputs must be an integer, a Boolean, and the output also must be Boolean. And for applying an AND gate, we needed two inputs so that it will be act as a binary operator. So normally the AND operator used to we need to test it whether if all the relational conditions are true. Then for those situations, we can go to logical AND operation. For example, let us check with the one basic condition. I want to check with where I am eligible for blood donation or not. Checking for the eligibility criteria. So there are two possible conditions need to be satisfied. One is I'm eligible. Means my age is greater than or above 18. Then I am eligible. And second condition is my weight minimum 50 kg. If these two criteria are satisfied, then I am eligible for blood donation. So here there are two relationships we need to check in. One with for age attribute, another one is for weight attributes. So I need to test these two conditions. So there are two relational operations I need to establish. So that is one is age greater than 18, that is a greater than or equal to 18. Another one is weight greater than or equal to 50. So these are all two relational operations. But I wanted if these two conditions are true, means if these two conditions are satisfied, then I am saying that I am eligible. So I want to make a decision by combining these two criteria and make a one decision. So that here both the conditions, both the criteria must be satisfied. So in this situation, I will go with this AND operator. Clear? That is called logical operator AND. Clear? So this is a simple example. Okay, so I will move on to that. That is, I mean, some example. So here I'm saying 5 greater than 7 and one is 8 greater than 10. So here just used, these are the two relational operators I used. So that here I combine it by using AND. So here that 5 greater than 7, this is a relational operation. So the output of this relational operation is false. And here also false. So just we must to know that truth table for a logical gates. So we know that no. So for this logical gates, normally assume that is zero is false is represented as a 0. So false is represented as a 0. And see, let us think about the truth table for AND gate. So 2 is representation to 1 in terms of logic gates truth table. So it is a false. And same way for a true, it is a 1. So just simply you can recall that the truth table for the logic gates. So it is false, and if it is a true, so it is 1, and here also it is true, it is 1. So it is also true. Okay, just you can same the truth table. Just you need to follow. Just instead of that, just you can replace this 0 as 0. I mean, it's a false, and 1 as a true. This is for easy understanding purpose. Doesn't mean that the true is represented by 1 and false is represented by 0. Doesn't mean that. Just for easy understand. Means for easier just to recall purpose. Just I can represent that false as 0. So we know that now for AND gate, if all the condition must be true, then only the output must be true. Clear? So this is the equivalent truth table for the logic AND gates. So see here, there is these two conditions are false, so that the output is false. Clear? Okay, let's recheck with some example. I'm going to test my condition. So that is 10 less than or equal to 90. This is the one relational operations. So normally, please use parentheses. You can group all the relational operations separately. Then you can combine. I'm going to say that 90 less than 34. So for this case, for 10 less than 90, less than if the condition is true, and here 10 less than 90 less than 34, it is false. So that the output is false. Means here in this indirectly it will be false, false and true. Sorry, true and false. So we know that if any one of the condition false, the remaining conditions also to be false. Clear? So see here, just I'm going to represent 1 greater than 0. And I'm going to say 1 greater than -3, and so 56 greater than 78. For example, 50 greater than 34. So here there are 3 relational operations are there, so that we are combining with the relational operator, means by logical operators. So here all the conditions are true, so that the output is also true. Clear? So like that you can express n number of a condition, n number of relational operations and connected with the help of logical operator. So normally we prefer to use this logic and logical operator. Want to make it, we want to check the criteria that all the condition must be true. So in this situation we can use to AND operator, logical operator to connect. Clear? Okay. So not only for a whole number, even it will be applicable for a fractional number also, because the relational operation has an input. So relational operation input, we know that the relational operator is applicable for a whole number and as well as fractional numbers. So the relational operation has input, so that the output of the relational operator has an input for the logical operators. You can use any operator. That's an important thing. Okay. Next one is logical OR operator. So here, only thing is, here the input also be in a Boolean operator. That means the relational operator as an input. And here, the purpose of this logical operator is, even we have a n number of conditions, there is a n number of criteria. From that criteria, if any one of the condition is satisfied, then I can say that you are eligible. Okay. For example, assume that you are applying for, let us take one simple example for you are applying for counseling. So there are different type of counseling were applied. One is for applying for engineering, one apply for medical, one apply for architect. Somebody, I mean, so you are applying for, you are applying for something for arts college, arts and degree. So there are different combinations are there. So if any one of that degree is selected, then you are eligible for the highest, higher degrees. Correct. So in these cases, only any one of the cases is selected. Correct. So like that, you are, if any one of the condition is true, then you want to test it, you can go with the OR operator. Clear. And so the working principle also to be an the associative principle is L to R. So here also the same truth table for OR gates. Just you can follow that. So that is. So only thing is, it is a 0, 0, so that it is a false. That is a false, false, it is a false. If any one of the condition is true, the output is true. It is a truth table for logic gates or logic gates. I think you already studied in physics, I think so. Just you can simply recall that. Clear? Okay. And the third one, it is a NOT operator. It is equivalent to the logical NOT gate. So the input must be as a Boolean operator, or it may be accept a number also, it will accept. It will accept whole numbers also. And the output must be Boolean and it must be unary operator, because for logic gate only one input needed. And the working principle is for left to right. So here the truth table for logical NOT is, so if an input is false, the output must be 0. The input is false, the output must be as a 0, that is true. Then again input is true, so then the output is false. This is for understanding, like representation of zeros and 1 representation, for just understanding. If you are giving input 0 for NOT gate, it given output is 1. Just you can replace as 0 as a false and 1 as a true, just for easy understanding purpose. Clear? And even we can support the numerical values also possible to give as an input, so that other than 0, if you are giving anything, it will be considered as a true. Even it may be a positive number or it may be a negative number. Before this, just we will discuss on OR operator as an example. So here this condition is false, but here this condition is true, so that it returns a true. I'm going to give the two conditions false. Here both the conditions, both the relational operations are wrong, that is a false, so that output is false. Not only like that, just even you can combine like this, 3, 4 R. You can combine like this. So for checking the condition here, more than one logical operators are there, so that we have to use associative principle for left to right principle. So that this is the working principle. The working principle is 3 class 4. This is a false. Will be represented as the false, or again 5 cross 4, that is 5 cross 4, that is 5 greater than 4, 5 greater than 4 is true, or 34 greater than 20, it is also true. Clear? Now we are going to work with the left to right principle, so that just you are going to combine these two, you are going to evaluate, so that the output of false or true, it is a true, again are true. Working in the left to right principle, now we are going to test this condition, so that the output must be true. Is it clear? So like that we need to test, so that the output of this operation is true. Clear? Okay, so assume that I'm going to do like this. I'm going to stop this and I'm going to use AND operator. Okay, so now you have to test it. The same thing. So it is true. Now I'm going to evaluate. So false or true, the output is true. So or true. Now you have to test it. True. So here again true. True. Here there is a small correction. It is and. So because a logical operator occurs more than one time, then you can use the POC principle of associative principle. So the associative principle is left to right principle. So that you have to left to right principle. So that you are going to evaluate from left to right. So that here we are going to evaluate OR operator first, then followed by AND operator. Here the true and the true, so that the output is true. So you are getting output is true. But here in case if I'm going to change something here, instead of this R, I'm going to use AND here, ending a mu to R. Clear? So here the working principle is just you are going to work with the AND operators now. So the priority, so that it will be as AND and it will be as OR. So here for ECA, so that here the thing is left to right principle, so that the false and true will be evaluated, but here it is and here it is changed as OR. So here the false and the true, so that output is false, because for AND gate, if any one of the input is false, so the output is also false. False output is a true, so that it is true. So you can not only for a 3, you can evaluate like that by using left to right principles. Okay, so now we are move on to the NOT operator. For example, NOT, I'm going to give that input is 3 greater than 4. So we know that now the 3 greater than 4 is a false. The negation of false. The working principle is like that. So assume that I'm going to use like that. So here NOT and so relational operators have a highest priority than logical operators. So that's 3 greater than 4. It is a false. Negation of false, so that it will be represented as true. So just I'm going to small correction. It is not symbol. Actually, in other languages only they use like this, but here it is a not. Small correction. It is a not. It is a not false, so that it will be true. So that I want to make a changes here, so that it is not. So it is a true. Clear? Even just if you want to change the condition like this, instead of this, I'm going to use operator changes. So that is called less than. Clear? So that if here not and 3 less than 4, it is a true. So that the output is false. Clear? Okay. So same way we have to test like this. And even if you are applying not 3 greater than 4, now you have to test like this. So we know that the 3 not will be eliminated, so that the actual output of 3 greater than 4 will be printed. So that is 3 greater than 4, the output is false. So not false, so that the working principle is so that is not false. Not false. So again, now we are going to evaluate from right to left here, so that the first one is not false. So not false is it is small corrections here. Okay, that is called not L to R, that is R to L. R to L is applicable. So if you work like this, and so there is a not. So a not false, so that it is not, and a not false is will be considered true. Again, the not true will be considered as a false. So that the relationship will come into play. False. Clear? Even so, you are getting that not false and 45 greater than 67. So like that, if you are going to express 4 greater than 3. So for this case, the not operator have a highest priority. So that the priority is so here the priority for not operator and these two operators have a equal priority. So that it will be evaluated from left to right. Here only we have a not operator, so that it will work only for left to right. So that and the first not operator comes to it will be evaluated so that it is not false. It will be as comes as it will be represented as true. True and 4 greater than 3, it is a true, so that output must be as true. Clear? So you have to apply it anywhere. I mean, so you can combine, but by using priority and association rule, so we need to evaluate. And even for we can apply like a not 5. So here 5 is a numerical value. Even the numerical value is applicable to 1. So that 5 means a 5 will be considered as a true. So not of true, it will be represented as a false. I'm going to say not 0, it will be represented as a true because a 0 will be considered as a false. So not false as a true. Clear? So not for 0.0, it will be as a 0.0 will be considered as a false, false, so that not false as a true. Clear? So not 0.1, it will false because other than 0, it will be represented as true only. That means if any number which is represented other than 0 will be treated as a 0, it is a true for not operators. So not, I'm going to say minus 1.0. So minus 1.0, in this case, it will be treated as true. So the not of true, it is false. So like that, we are going to work with the concept of logical operators. This I can recall once again. The logical operator is to combine two or more relational operations. So that there are 3 logical operators will be supported by Python. One is AND, OR, and NOT. AND and OR, it's the binary operator. NOT is a unary operator. It needs only one input. And so the logical operators, that means the NOT operator is applicable for both numerical values and as well as Boolean values. But AND and OR operators normally it's suitable for logic. Boolean. But even we can able to apply the numerical value for this, but the working principles are different. We will discuss in later part. And the evaluation principle of a logical operator is up to L, and the remaining will be work with left to right. And for while evaluating the numerical value, that other than 0 will be treated as a true, and the 0 will be treated as false. So this is the way we should work on logical operators. Thank you.